Damaged right now. So anyway, just to introduce the program, for those of you who are here in October, you know what this is about, but for those of you who weren't, welcome. And on the board, you know, sometimes we engage in very high-level strategic discussions going forward, and those kind of have to be in smaller groups. But other times, we're privileged to get informational reports about what's going on in the school. And a lot of us have thought over the years that these reports are so great and so inspiring that it would be great if they reached a wider audience. So this year, on kind of our informational reports, we've asked Home and School and Gina Miller and Tasha Hatton to invite parents and a wider group to hear these reports. So last year we engaged in about a year, 18-month, and I see Akemi Lakan is here and she chaired it on the board. Thank you, Akemi, for the strategic plan. So you know, we have a high-level mission and values, but the strategic plan is kind of a every 3 to 5 year roadmap of how we want to implement these goals and further our mission. So today is about the second prong of a three-pronged strategic plan, which is provide the Intermountain West's most outstanding math and science program. And I can't memorize this, so I'm just going to read it. While remaining committed to educating the whole child and offering an incomparable learning experience in the humanities, arts, and athletics, we will develop new opportunities for students in mathematics and science. We will challenge and excite each and every student by strengthening our math and science curriculum, learning objectives, and instructional and assessment practice school-wide, evaluating methods of incorporating technology and engineering into curricular and extracurricular activities, making math and science education accessible, engaging, and appropriately challenging for every student, and communicating school success in math, science, technology, and engineering. And so when Wendell Smith came on, Wendell came on, we challenged him to look at our math and science program first. And so that's what we're going to hear about today. The timing of this couldn't be better. I can't make this stuff up. But if you read the Trib, yesterday's front page headline was New School Science Standards on Hold. And the article starts out, I'll just paraphrase, but the article starts out with a middle school science class outside, and they have an experiment to have a rocket or some propulsion mechanism to throw a container up in the air with an egg in it and have it come down, and the challenge is to have the egg not be broken. And so they focus on a kid who his thing comes up and he opens the package and the egg's all over the hands. You know. And most of the other eggs are broken too, and the science teacher's very upbeat and says, hey, this is great. You know, we can now go back to the drawing board, see what we did wrong, what could we do better, how can we make it better next time. And so I thought, how lovely, how nice is that? And you know, it involves engineering and math and physics, and this is 8th graders. And then you read on, and the program to revamp science standards and math standards at the state level is now on hold because there was some objections from parents and legislators and other groups that they were using, I'm so sorry. They were using national standards, and they weren't Utah enough. So I emailed Richard yesterday and said, you know, if this isn't an advertisement for what we on the board call the value proposition of Rowland Hall, what is? Because we're not on hold, we're moving forward. And I even, you know, kind of snidely said, I didn't realize the laws of physics were different in Utah. Well, I swear I didn't talk to the Trib's editorial board, but let me read you the lead editorial into this morning's Trib. Utah, I won't read it all, I promise. Utah is an exceptional place, beautiful scenery, industrious people, fascinating history. But no matter how much some might wish it otherwise, the gravitational constant of the universe applies here. So do all of the other laws of physics, chemistry, and biology. There is no Utah way for objects to fall, for heat to be transferred, for cells to divide. E still equals MC squared, even in Utah County. Which is why is it absurd and more than a little embarrassing that a committee of the Utah State School Board is waffling on adopting a new set of science standards for the state's public schools in part because some folks think that the standards are somehow not Utah-ish enough. Well, enough said. We're not on hold. We're moving forward. And I'll turn it over to Wendell to explain where we're going and how things are going at Rowland Hall. So thank you all very much for coming. And let's hear it.
Thank you, Ira. And that's a great story. And it's going to seem like we were colluding before the presentation that I'm going to give is over, because I'm going to be touching on some of the things that he was just talking about. So we are focused on the second goal of our strategic plan. First of all, thank you all for coming. It's terrific to see so many people here. And I'm a little bit nervous, like I always am, standing in front of a group, but I'm also really pleased to be here reporting what I think is some great early progress that we have made towards the goal that we have projected on the screen here. I think the teachers and principals and all of the support staff, Christian Waters, our Director of Technology Integration, they've all contributed significantly to some of the progress that we've made, and I'm just happy to be able to report some of that progress. So, I have some news to share about the progress that we've made, but before I get to sort of the news, one of the things that struck me when I arrived at Rowland Hall and read the strategic plan is that there must be some perception that there is a problem with math and science, and absolutely, when I talked to math and science teachers, they felt like, yeah, what are we doing wrong? What's the problem? And so in the summer, I looked at a lot of the data from standardized tests, from the different assessments that we give internally and externally to our science and mathematics students. And all I could gather was evidence that we're doing really well. And so I just want to spend a minute on this notion that we are focused on improving our science and mathematics programs. Just like any great school is focused on continuous improvement in every area all the time. But we are not starting from a place of weakness. We are starting from a place of strength. So here are just some recent test results, and I will make the point in a minute that this is not the only thing by any means that matters to us, but it's a measure of how we're doing in mathematics and science. So in our AP exams, we as a school give 27 different AP exams, at least we have over the last 5 years. Of those 27 exams, you can pretty well categorize 7 of them as a science math group. And even though only 7 out of the 27 AP exams that we give are math and science, half of the exams that our students write are math and science exams. They are flocking to those courses, and they are doing really well on those exams. So half of the students taking AP exams are sitting for math and science exams, and half of the perfect scores of 5 that our high school students have earned in the last 5 years have been on those science and math exams. So they are doing very well on those measures. The PSAT exams that our 10th and 11th graders took this fall, the results just came back. Bruce shared those with me last week. And again, to give you an idea of where we are as a school, the median student in the 10th grade, so that is the middle of the road mathematics student in our 10th grade class is in the 84th percentile nationally. So our average student is a very strong student in mathematics. The same is true in 11th grade, 83rd percentile. But one of the things that struck me more than anything else in looking at the PSAT results was that there's a questionnaire at the end of the test where students choose what they perceive as their future college major. And 56% of our 11th graders chose a STEM major as their expected college focus. And so we are doing well, and we are clearly inspiring students to pursue those ideas, math and science related. And then the ERB test, just to give a sense of some of the younger students' progress, this is the second year in a row that the 6th graders have taken a science portion on the ERB test. They hadn't done that until very recently. And for the second year in a row, that was the highest category that they scored in out of all the other categories measured on the ERB. And it was a category that they excelled beyond what our peer schools students showed in terms of science achievement. So when we look at high achieving independent schools, our kids on the ERB test in science were doing better than those peer schools. So again, we're doing pretty well. And then going back to what Ira was talking about, this is not what matters. If you talk to the teachers, they're happy that we do well on exams, but they want to inspire students. They want to create this love of science and inquiry. And so this is a picture of a 6th grade field activity. That's 6th grade science teacher Molly Lewis. And I don't know who the blonde-headed kid is there. The back of his head looks familiar. They went out multiple times this fall when the weather was nice and went into the foothills, collected data, did field experiments. These are the kinds of things that are going to inspire our kids to continue to pursue science and technology and engineering. And these are the things that our teachers are passionate about, and those are the kinds of things that apparently perhaps are running into problems with the state legislature. Okay, I want to shift the focus now to some things that we're moving forward towards. This is sort of a look at where we are, where we've been, and now I want to look at some things moving forward. This fall I read a Brookings Institute article about early childhood mathematics, and it was one of a handful of things that I've read in my career that immediately changed the way I think about education. That Brookings article referenced this article. This is from the journal Science. This is the Journal of the American Association for the Advancement of Science, one of the most prestigious scientific journals in existence. And the article is written by Douglas Clements and his wife and research partner, Julie Sarama. And it's about the importance of early childhood mathematics. And I just want to go over a couple of the ideas from that paper. Dr. Clements writes that mathematical thinking is cognitively foundational. Preschool children's knowledge of mathematics predicts their later school success into elementary and even high school. Further, it predicts later reading achievement, even better than reading skills. And the study of mathematics in high school predicts college science achievement across all subjects. So, and he's not just saying this, there is sound research backing to all of these notions. So if we can do things right, if we can give our beginning school students the best possible mathematics start, that lasts not just through their primary years, but into high school. And it's not just the mathematics. it's a better predictor of reading and literacy skills than reading is. So if you test a kindergartner in mathematics and reading, the mathematics is a better predictor of later reading skills than the reading is. And I know from a huge study that was conducted about 8 or 9 years ago from Harvard that if we do well in mathematics in high school, then the world of science opens up at the university level. The best science students are always the best high school mathematics students. The best university science students are always the best high school mathematics students. So if we can get things right in the beginning school, this leads to success further and further down the road, and not just in mathematics, but in all subject areas. Well, Dr. Clements and his wife are the authors of a mathematics program called Building Blocks. Building Blocks is one of the very few commercial curricular programs that is found to be able to raise achievement in different student groups, different school settings, and there is a What Works clearinghouse that the Department of Education operates, and they have very high standards for what they will give a check mark and say this helps students learn better. And Building Blocks is one of those programs that does that, and we use Building Blocks. Carol Blackwell is a longtime admirer of Dr. Clements, and the beginning school adopted Building Blocks 2 years ago, and for the past 2 years they have been working on implementing this curriculum to improve the mathematics education of our beginning school students. And it focuses on the 4 main areas in mathematics: geometry, measurement, number sense, estimation, and proportion. And these are some pictures, and all I had to do was send an email to the beginning school faculty, and within a day I had 100 pictures of beginning school students engaged in this type of mathematical investigation. It was really rewarding. So I thought, what the heck? And I just wrote an email to Dr. Clements thinking if I got a response, I would be pleased, I would be amazed. The next day he wrote me back, said he was going to Ireland to present, but that when he came back we could talk. And I'm like, talk? Okay. And he gives me his phone number, and then he calls me, and then we had a conference call with Carol Blackwell and myself, Dr. Clements and his wife, Julie Sarama, and we talked for 45 minutes, and then we engaged in an exchange of emails back and forth, and now I am over the moon, and I think Carol is over the moon, happy to announce that he's going to come here in August to do a professional development workshop with our beginning and some of our lower school teachers. And what he will be doing is working on the learning trajectories that are built into the Building Blocks mathematics program. Learning trajectories are ways that teachers can measure the progress of students. They can identify the level that the student is on in the learning trajectory, and then they know where they can push the student to get to the next and the next and the next level. And the art of this, as a teacher, can potentially take years to find out, okay, through these observations I can tell that the student is on this level. And the kind of workshop that Dr. Clements will be helping our teachers with is to get them to a higher level than they already are. They're already working in this direction. This will jumpstart that. And then after the workshop, we'll be working with his group at the Marsico Institute at the University of Denver for the rest of the year next year, and I hope beyond that. And I just wanted to share with you a little bit about what that looks like.
One of the other interesting things to us
Here's,
is in the 2 domains, geometry and number.
Here's Dr. Clements. And if you can't hear, let me know in the back.
Let's talk mathematics for a minute. And I'd like to start out with a brief story of kids' potential for mathematical thinking. These kids have been doing some of the mathematics that we feature in the curriculum, but the puzzle you see right there is not from the curriculum. They had just pulled it off the shelf. And the little boy Corey started solving this by putting 4 triangles together, 4 triangular blocks together to make a square block like I've pictured in the upper right hand. Now, the little boy next to him, the boy in pink, can you see his hand? He put 2 of those triangles together to make a block, but that didn't fit. He thought he was doing the right thing, but it didn't fit, so they had this long discussion about it, whereupon this boy showed the teacher the finished one, because they all got together and then finally finished the puzzle, and the teacher said, so how many blocks do you use? And he counted 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 24, good counting. Then the teacher didn't stop. She said, how many, 24 what? He said triangles. And then, how many squares do you use? And then he took his little finger and he left 4 fingers pointing down, put them on each of the 4 triangles. There it comes, 1, 2, 3, 4, 5, 6. So before I tell you what Julie and I think is important to that, I want you to think pair share. What do you think we think is important mathematically about that, okay? So think for a minute, then talk to the people next to you, and I'll only give you 1 minute, because I don't have much time up here, but 1 minute to share with the person next to you about why you think we think that's mathematically interesting. Go ahead.
So I'd like for us to engage in this think, pair, share activity. So this is the puzzle he was talking about. You can see the 6 squares, each composed of 4 triangles. And the one boy hadn't quite figured it out, but the boy holding the puzzle here was the one that curled his pinky up and did the 1, 2, 3, 4, 5, 6 to count the squares. So what do you think might be the important mathematical idea behind that?
We're starting a group.
We're not going to think pair share. So can you talk with the person next to you for a minute and see? We're going to think pair share. I did hear an idea before. It was a grouping. Yeah. And what other ideas do people have about what is mathematically important about what the boy was able to do and what the teachers were able to observe there? Anybody else want to share an idea?
So it's kind of the fundamentals of multiplication, right? Because if you can get him to understand that 4 times the 6 that he's just counted is 24, I think that's pretty young for multiplication. I don't know exactly.
It would be very young for multiplication because I think that boy is 4 or 5 years old. So
Patterns.
And I think it is a pattern too. Let's let Dr. Clements say what he thinks is important. Can anyone tell that he's a former kindergarten teacher?
There's one. Shapes are important. So he knew shapes, that's cool. Numbers important, that's cool. But one of the other interesting things to us is in the 2 domains, geometry and number, that are most important to early childhood, they made units of units. What am I talking about? He could count the triangles as triangles, but count them as a unit together as one object. He could see the triangles as separate shapes, but also see them as composing a larger shape, a unit of units. And that might seem esoteric and all, until you think in 2nd grade, when these kids get at that level, when they're doing multi-digit addition and subtraction, they have to think about a 10 as 10 ones and 1 10, and be able to move back and forth between those 2. Here are kids forming the cognitive foundation, just that kind of thinking.
And I'm talking too long, so I'm imposing upon Tyler's time because he wants to share some things about middle school mathematics.
I have a question for you.
Yes.
Can these tactics be used for remediation, or are they just predictors?
For remediation in the sense that we can identify where a student is developmentally
Like
and then target interventions, absolutely.
He doesn't like puzzle pieces, doesn't like figuring out shapes and how things fit together, or patterns like that. Can you use them to bring them along?
Yes, because if we see that a student hasn't made some of these connections, doesn't understand the significance of some of these, then there are activities in the building blocks program that would say, okay, then this is an appropriate resource for that student. And if the student is at that level, it would also identify what the next steps are for a kid who's already moving to that next level. So I want to pause for a minute because our middle school principal, Tyler Fonro, has an appointment, and I've already impinged upon his time. He has some things to share about middle school.
Thanks, Wendell. And yeah, I'm Tyler Fonero. I'm the middle school principal, and I'm going to take advantage of your fully formed frontal lobes and assume that you can take a break from this so you can listen to middle school, because I have to go meet with the 8th graders who don't have fully formed frontal lobes. And they need to hear from me now. And we have a discussion at 9:15 that I'm facilitating. So Wendell asked me to share a little bit about math and science in the middle school, and I actually studied math and science at college, so I actually know what I'm talking about a little bit. And what I'm really excited about for middle school is some of the things that is actually similar, quite frankly, to beginning school, is experimenting and playing and making mistakes and trying to really get out into the blocks or into the world, and that's what we're really trying to do at the middle school. We have math is a very linear, can be a very linear progression. You usually want to learn one thing before the other, and so what happens in math, particularly around the middle school age and quite frankly in lower school as well, is kids' abilities start to do this. And it's the teacher's job in the middle school particularly to be the master of understanding what students' needs are at different times. We do have the compacted math program in the middle school, which allows for a more advanced program for our innately strongest students, but there are always outliers. So we have 3 middle school math teachers, and they teach at the grade level, but they're frequently doing project work and group work so that they can clump them in ways to challenge them where they are. We have outstanding support services for students who really need that additional support. We also have a few outliers at the top that are taking classes above even their compacted grade level. So we really are able to reach students where they need to be. In the high school, where grade levels classes are mixed, it's a lot easier because they can teach a course like pre-calculus no matter. We have an 8th grader, for example, in a pre-calculus course right now. He's been in the high school for 2 years. So they have that opportunity to blend an 8th grader with a senior, for example. So those are some of the things how we do our core curriculum. We're really excited this year to be doing math counts again, which is a national competition for our strongest math students. We just competed on Saturday. I was the math counts coach. It was fun for me. I think I competed in the first 2 years of math counts in the 1980s. And I was surprised that I didn't realize I was the guinea pig group in the mid-80s, but that's when it's 30 years old. And they do regional competitions, and in a month we'll be doing the state competition. We took 3rd place in North Salt Lake, which we're really excited about, with 2 6th graders, a 7th grader, and an 8th grader, which tells you a lot about the diversity of learners at the middle school, that we had some of our brightest students aren't necessarily in the 8th grade. And quite frankly, the kids who are advanced in math are the ones who are more attracted to these contests, because that's what it is, it's a contest. But and so they did really well, and one of our 8th graders, actually the one that's in pre-calculus in high school, placed 3rd in the region, and he'll be qualified for state next month, which is pretty exciting. So we're really trying to push our brightest students as well in that area. One other piece about math that I think is important that Wendell brought up is that our best students in math high school tend to do well in science. Best is an important term we have to define. Is that meaning that they're the best score in math counts? Absolutely not. They're strong thinkers, they're strong collaborators, they're working hard. It's not just, I didn't study and then aced a test. So we're not just looking at the students with the highest GPA or the highest percentages on those tests. We're looking at the students who can be strong thinkers as well, because that's really not just be able to do the computation, but actually be able to apply it, and that's really what science is all about. Which takes me to some of the exciting things we're doing in middle school science right now. You saw the picture of Molly Lewis on that field trip, which was in September, which is really neat. We've got a new opportunity this year in the middle school to shift around our schedule. So teachers have 3 hours of dedicated time per week to actually get together and plan curriculum and best practice and ideas with their colleagues. If you look at the strategic plan, one of the biggest constraints is time, and we were able to pull some magic around to create that time. That field trip was tried for the first time this September. If any of you teachers in the room know that, do you really like to try new curriculum the first month of school? The answer is no, because you're just getting to know the students and you're just trying to get your head on straight. And they had the opportunity to say, let's do this because it gets the 6th graders out in the world, which is what we want them to do. It was a cross-curricular math and science activity where they're measuring a grid and doing density in the field. That picture was above Red Butte Garden. And if you didn't get the inside joke, that blonde was Wendell's son. And so they're out there doing that. They also have the opportunity to go back seasonally and see how things adapt, which is a science concept we're looking at. How it looks if there were snow out there today, which there should have been, something they can't predict. And that goes on through 6th and 7th grade, our engineering program, which is a high school program that we do with our 6th and 7th graders with the BYU engineering program, where they crash bridges to see who can build the strongest bridge. And then the new project in 8th grade that I'm really excited about is our science teacher, Sarah White, has done a snow science unit, which is, again, other Salt Lake City schools could claim to this, but we do. And we're the one, because other cities and schools around the country can't do this in the sense that we're going up to, a 20-minute drive to Big Cottonwood Canyon and getting into 6 foot, well, probably not this year. Maybe if we hike a little higher, but we have new snowshoes in the middle school. We can actually integrating science and PE, and we're going to hike up to higher snow and find pure snow out there. And doing snow science, where they're doing chemistry, they're doing measurement, they're doing statistical analysis with this equipment that we have, thanks to some, to our budget with math and science, and get out there and actually do some true science. And our hope is that we can do that kind of thing in partnership with science institutions and universities, so that they can actually use the data. Because that's a really big movement in the last 10 years around community service, is switching to a citizen science model, where they're actually going out and doing data collection for universities and things like that, so that we can help use it in a meaningful way. So those are just some of the quick things that I think I really wanted to highlight in the middle school, and I'm sorry to be out of order, but I hope you can compartmentalize that between the lower school and upper school comments today. So thanks for your time.
Thank you, Tyler. So I just wanted to follow up. Snow science students are going to be heading up there this week. I think Thursday morning I'm going to go with Sarah and accompany her with the 8th grade students. And it's, again, taking advantage of our resources. And it's, again, touching on some of the things that Ira talked about at the beginning. We're taking advantage of those things. Also touching on something that Ira talked about at the beginning. When I came in the summer, I had a workshop with science and mathematics teachers, and one of the things that we talked about was the next generation science standards, which, as a department coordinator at my previous school, we had adopted for the middle school and the high school science classes. Next generation science standards are a group of science standards that were developed in a collaboration between the National Science Teachers Association, National Research Council, American Association for the Advancement of Science, and a group called Achieve. It's a nonprofit educational think tank. And they did this right. They got the scientists and the teachers together to think about how this would fit best in classroom settings. They put the standards through several public viewings and revisions. So they published them, had science teachers and teachers in other areas send in their feedback. They did revisions. This happened 2 times, 2 public revisions, and then the final standards document was released in 2013. What is powerful about the Next Generation Science Standards is that it is a vertically and horizontally aligned set of standards. It's a framework for teaching science, not only K through 12, but it's a framework for teaching science within the context of all of the other disciplines, because it is pre-aligned to mathematics and language arts standards for the Common Core. And we're not a Common Core school, but those ideas are similar in our English language arts departments and our mathematics departments. So I just wanted to share with you all that Kirsten Walker, our lower school science specialist, and the 3 middle school science teachers have really committed to adopting these standards.
Are these the standards that the state legislature is pausing on, or is that something different?
They are. If you read the article in the Trib, this is the basis. This was the starting point for the state, for the Utah standards. And the Trib didn't go into it that much, but if you read between the lines, what I thought, this is, I'm not on a soapbox, but I think if you read the article, it seemed like most of the objections were from parents or legislators saying, there's elements here of teaching about climate change or evolution, and so in the editorial today in the Trib, they said, you know, the politics of climate change might be controversial, but the science isn't. So, you know, that's what most of the source of the objections were.
Okay. Yeah.
So these teachers have done a lot of work starting back in August, and Kirsten has really been one of the people who spearheaded this. Those 4 teachers did a full day online virtual conference back in October. They didn't have to do it, they just did. And they are moving towards adopting and starting the process of implementing these standards. And I just wanted to share with you some of that work. Here is what the Next Generation Science Standards Appendix K offers as a sample of how you could arrange. Now I know you guys can't all read this, but what they did was release middle school science standards in life sciences, physical sciences, earth and space science, and engineering. And they didn't say, teach this in 6th, 7th, or 8th. But then they assumed correctly the teachers would say, so what do we do in 6, 7, and 8? So while they had the experts together, they took all of those standards and started doing this. Well, what about this for a 6th grade course, this for 7th, and this for 8th? And our middle school science teachers over the past few months have been meeting whenever they can, and this is what they've done with that. And what's terrific is they're taking ideas and lesson plans and projects that they know have worked for them and for their students in the past, and seeing how that fits within this framework. And that's the first step towards the implementation. And I love this post-it notes here and up at the top, do more, do more. They're saying, oh, that's a gap. We've recognized a gap. We can do better right there. And so this is great work that they're doing. And when Tyler talked about them having the extra time this year, this is one of the benefits that you get. You can really take a critical look at what you're teaching, your scope and your sequence. And that's a luxury that not all of the teachers have right now. We're working on it though. And next I want to ask Kirsten to come up and talk to us. Deborah Walker, our lower school teacher. Deborah, I just said Walker.
Hey, I said Smith.
Debbie Walker is a friend of my wife's. I don't know where that came from. I guess it was a mixture of Kirsten and Deborah. Thanks. And they're going to share some of what they learned about at the NSTA conference that they attended in December.
It's good to know we both have senior mom.
Okay. Before I get into, we have a couple videos to share with you, and I'm going to introduce a few others from lower school who joined me at that conference in just a moment. But I just want to start off by saying that a couple years ago when I first interviewed at Rowland Hall, I asked the question, what really sets Rowland Hall apart from its other, peer schools in the area? And I would say today, if I had to answer that question, for me, it's our lower school science program. Of course, that's biased. I'm a lower school science teacher. But more specifically, I'm actually referring to my colleagues who teach science with me. They are not your typical elementary level teachers right here who shy away or are fearful of science. They're the exact opposite of that. I feel privileged to work with such a passionate group of educators who totally love to teach science. And so, of course, you can imagine when we got the opportunity to go to a science conference. This year was my second. I've gone to 2 in the last 2 years. And this year, they opened it up to a teacher at every grade level within the lower school. And the teachers totally jumped on to that opportunity. And we're excited to go. So what we're sharing with you today is really just the tip of the iceberg. We learned a lot. We were in Long Beach for 4 days, and we've brought a lot back with us, and we're trying to implement where and when we can. And we're really excited about the changes we're already seeing and the changes we foresee happening in the lower school science program. So just to give you a little bit of a premise for what we're going to show you, we're going to show 3 quick videos because I think it's kind of neat for you to see what's actually happening in the classroom. Please excuse the videos a little bit because I threw them together this Sunday and I'm not an iMovie expert, but I tried my best. And they're going to show you in the first 2 videos, we're going to show you what's called an assessment probe, a formative assessment probe. And these are assessments that are designed to do several things for our students. To give deeper insight, well, and for us as teachers, but to give deeper insight into our students' thinking, to inform our instruction, which is huge, right? If I have a group of students that already completely understand one concept, there's reason to move on to the next level. But you need to know that about your students and when it's the right time to move on. Fostering rich discussions where all voices are heard, and eliciting common misconceptions. Misconceptions in science are huge. If we don't address those, students go on and carry those with them, and it makes learning at the higher level in science that much more difficult. So we really want to get at those at the young age in lower school science. So this first clip we're going to show you is the 2nd grade. It's called the Mitten Probe. And I'm actually going to just super quick show you the problems, okay? And it works out that, oh no, it says Sarah, not Katie. This is for Katie's class, Katie Schwab. And so basically, in a nutshell, it's asking the students what they think the temperature will read inside the mitten. You have 2 thermometers, one sitting out, just same room, same area, and there are 3 choices. It's either going to go up, it's going to go down, or it's going to be the same. So what you're going to see is Katie's students, she was facilitating a discussion about their predictions. And I just want you to pay careful attention to how she's facilitating. Being a facilitator is another big idea right now in education. Learning to teach not just by lecturing at and talking to students, but getting students to engage and talk to each other. So, and to really dig deep. So let's see what we got here. And then Katie will follow up for a little bit afterwards.
I kind of think if the thermometer was inside the mitten, then it would probably be a little bit warmer than outside, because outside on the playground, when we have no mittens on or gloves on, the metal is really cold. But when we have mittens on, it's not as cold. So I'm thinking that it might be a little bit more warmer in the mitten than outside.
Warmer in the mitten than outside, and I really liked that example that you gave us based on experience. Anyone else? Go ahead, Julian.
I think the temperature would go down, since when I put my hand in, the mitten doesn't go I just leave some on the floor, and then it gets colder because at night we don't have any heater on, and so it will get cold, and then in the morning I put my hand in it and it's cold, and I have to use body heat to warm it up. So if the thermometer went in, I think it would go down.
You think the temperature would go down if you put a thermometer that was just at room temperature? You think if you put it in, it would get colder?
Well, if you put the thermometer in the mitten for about like an hour, it will probably go up, because if you just put in for a minute, it's probably gonna stay around the 30. But if you put in longer, it gets warmer and warmer and warmer. And so then it'll probably be up to the 40s or the 50s then.
So you're saying that you almost need to leave it in there longer for the temperature to go up? Is that what I heard you say?
Yeah, or
okay.
It depends on the weather, because if you put it in when it's 35 degrees out and you block it up, then it'll probably get warmer. But if you do not block it up, it'll probably get a lot colder because the wind is inside of it, because the wind is a lot stronger than the material.
Okay, what do you think?
I think I agree with Eve.
And what is that? What do you agree
I
with?
think that if it was outside and it was a warm day, it would go maybe down, and if it was a cold day, it would go up.
What about, so what's your evidence?
That
I mean, what experience have you had that tells you this to be true?
this was when I was a little bit crazy when I was a kid. I was going skiing, and I put on a glove, and I was like, "Whoa, that's warm." And then I think then the next, I think there was, well, then the next day it was really, really warm for a winter day, and so I put on my glove, and it was really, really warm.
Okay. Is there anything anyone else might like? This is true or not? Well, first of all, I hear Kaya sort of changing, sort of moving her prediction a little bit based on something that she heard from Julian. And I like to see that. Is it important for us to listen to one another to either confirm what we thought or to say, wait, maybe what I thought was not so right? And I love that you, Kaya, your mind's sort of flexible and that you're willing to hear different arguments and not just like stand with your first prediction, whether it be right or wrong that you moved or stayed the same. It sounds like most of us, or most of you, thought that perhaps the temperature would go up, or it was dependent on the outside temperature, right? Right, Ainsley? Okay. Except for Julian. Julian felt like body heat had something to do with it, based on his experience of putting his glove on and having it be cold when he put his hand in there. So I'm wondering how we can test this. What could we do to test this? Any ideas? James, what do you think we should do?
We should put a thermometer in a glove.
Okay.
And put it outside for an hour, and then put it inside for an hour and see.
Okay.
Because someone out there said that it was for an hour it would get warmer, and for a minute it would get colder.
Oh, okay. Oh, yeah, to kind of test. Because Lucy thought maybe the amount of time that it was in would make a difference. So let's see. Should we get a mitten? Does anyone have any mitten? Do you have any mittens that you would be willing to use for our experiment? Do you?
I think I might.
Okay, will you guys go get some mittens if you have them?
I have a mitten.
Fantastic. Thanks.
All right, so that's that one. And Katie's going to just follow up with what's happened in the classroom since making the predictions. Whoops, wasn't that great?
Yeah.
And one thing that I took away, and I think most of us took away from that science conference, is that we talk too much as teachers. We just need to listen and teach them how to listen to one another and teach them how to respectfully disagree or agree. And believe it or not, I mean, the kids love to do this. We could sit for an hour talking about these things, and you think that they would just be, I don't think they looked too bored, do you? No, that's really, that's pretty awesome. And it was easy for me because that's really all I had to do is sit back. I mean, it really has been great in our classroom, and again, to get to the bottom of their misconceptions. And I asked my 8th grade middle schooler what would happen, and she said, well, absolutely the temperature will go up. So if you think about it, if we don't get to these misconceptions early on, then something like that's, you know, the difference between a generator of heat and an insulator of heat, that applies in many areas in science. From there, we went just quickly as we decided how do we want to set this up, and it was all based on what they wanted to do. The first time we set them out, and then they hadn't even thought about how one would need to collect their data. And no one suggested that we need to find out the temperature before we put it in the menu. So we went through that, failed, decided what we needed to do, and you have to give it time. It's not just something you do in a day. In fact, we're still working on it because I still have stragglers that are like not convinced. So then some of the Some of them wanted, oh, we need to tie up the mitt, we need to tie up the glove. And then finally someone suggested that perhaps we put someone's hand in it, put the thermometer in it and walk around the playground, and we found that it went up. But even though it did go up, they still are having a hard time figuring out why it went up. We know the difference is the hand. And as you saw Julian, who immediately had recognized, but 1 out of 18 kids thought that it would go up, which was amazing. And now they're learning on their own really how to set up and collect their data in a organized manner and how to make conclusions based on our experiments and what we can and cannot say.
But your approach is so collaborative and inclusive that no one is singled out if they're wrong. It's still, everybody is involved in figuring it out, and it's just beautiful to watch.
Oh, great. Well, and setting the stage, I mean, we had a nice conversation about agreeing and disagreeing and respectfully disagreeing and keeping our thinking flexible, and that it's okay to go back and forth and wait, now I agree with you. Wait, no, you're right, now I agree with you. And it's really cool to see. So,
thank you. Thanks, Katie. Now Sarah Declan's going to introduce her next, a little clip from 4th grade.
Hello. So as teachers, we strive to create a classroom environment that students feel safe to share their thinking and their ideas. And what my takeaway was from this science convention is that I learned that there are specific strategies that you can create through these probe activities or other activities that structure discussions that expose students to other students' thinking, and that they are forming their own thinking. It's a process. And through new evidence that they discover through experiments or reading, other class discussions, that their thinking can change. And I think that's a real powerful piece. An exit slip that I like to use after a science discussion or a lesson is, I used to think blank, but now I know blank. And I like to use that after my science discussions and lessons, and it just teaches the kids how powerful it is to learn new knowledge and to change your thinking, and yeah, so it's really exciting for me as a teacher. So this clip that you're about to see, the audio isn't as great as Katie's.
We were trying to teach,
yeah, we were teaching and filming
at the same time.
But this next clip is a probe that Kristen and I did in the science lab. It's called Wet Jeans. And the kids are learning about the understanding of the process of evaporation. So in 4th grade, we are studying water and the characteristics of water. So we decided, did you show the probe? Or you show the probe?
No.
Okay, it's called Wet Jeans. The kids had a scenario. It looked very similar as far as the setup as Katie's mitten probe. And then they had 4 or 5 choices, I can't remember now, to choose from, like what was the best answer. And then they had a piece at the end where they had to defend their thinking. I chose Kirsten's thinking and why. So that's an important piece. So they put that down, pencil, paper, individually. So we decided on an activity called commit and toss. So the kids, it's anonymous. So they do get a piece of paper, but they don't put their name on it. They read the probe, they do their thinking, they choose the best answer that they think is the best answer, and they defend their thinking in writing. They crumple up their paper, they toss it, we're in a circle, it's like a popcorn machine, pop, pop, pop. You played music, and then the music stopped, the kids grab a piece of paper, they unfold it, and they have now somebody else's thinking in their hand. And we grouped the kids, like everyone who agreed with Kirsten, everyone who agreed with Sarah, whatnot. I believe there were 4 groups. So those kids got together, they read the answers and the thinking of those kids who chose that answer. And then they had to come up with a summary of what those kids thought to the class. And then from there, and we tallied it.
Yep.
Just to show all the different thinking. 6 kids chose A, B, C, D, whatnot. And then we had another discussion about just all the different thinking in the classroom. And what I think is powerful about this particular activity is that the kids, they're not defending, but they're explaining somebody else's reasoning. And through the process of that, your own thinking is changing. You know, how can it not? It's just swirling around in the brain. So anyway, that was really exciting. That was the first session of that probe, but just like Katie, it's going to continue because not everybody chose.
Yeah, we had quite
the right answer.
So we know different thinking.
This informed us that there's still a misconception with more than half of my students about the process of evaporation. So I will be now, Kirsten and I talked and we're like, okay, what other activities, experiments, what can we do to change their thinking in the right direction, the misconception. So anyway, you can see what we did in the lab.
How all of our papers think that it's evaporation and how it's about heat, because a lot of us said it was about heat making it evaporate. So that's. We think it is C because the heat of the sun hit the jeans and it made the water evaporate into the air as a gas. That the water from the wet jeans moved up to the clouds, and this is part of the evaporation cycle, and so it goes up into the clouds, then rains back down. Water soaked into the ground because it is too heavy to evaporate before it hits the ground, so it had to hit the ground and then evaporate. We think that the letter E people think that the water chemically evaporated from the sun, turning it into vapor.
How might we go about figuring out what the best answer actually is? What do you think we could do? Ernie? The internet. How about, yeah, raise your hand and tell us if any of your thinking has changed, even if it's just a little bit.
And you don't need to share what.
Also, what we kind of did today, I know my thinking has changed a little bit.
Sarah and I have done these with other science teachers. And we've done a similar probe, it wasn't this exact one, where the answers from a group of science teachers, right? And they were
all spread out. And we listened to all the groups defend the thinking of those ideas, and it was fascinating. And I can share with you that my thinking changed a little bit after hearing what other groups said.
What did it take for people to change their minds? Natalie. Evidence. So I just want to say I pulled out this little part from one of the books we brought back from the workshops we went to, and it's about, one of the probes is about taking an object and asking students if they think it will float or sink after you drill holes in it. And this is a really tough one for the little ones, like first, second grade especially. And here's the quote from the book in the explanation for, teacher background. The idea that an object that has holes in it will sink is so strongly held that some students are convinced that there are not enough holes in the object or the holes are not big enough. Instead of correcting them or ending the investigation and giving students the answer, let the students make more or bigger holes. Eventually, they will see that the material still floats, the same way as it did before the holes were poked through. This leads to the most important part of this probe, revising an explanation when observations do not match the prediction. This is not just difficult for students, this is difficult for adults, this is difficult for all people, and there is a recent National Geographic article related to this, so look for that about the difficulty we have changing our minds when presented with evidence. So, I'll just leave that food for thought. The last little bit, I'm going to steal 3 more minutes to show you another big thing. I've been to 2 science conferences in the last 2 years, and I'm really working hard to incorporate more and more engineering. And engineering is not just robotics, but it's a lot about a design process, a process of that involves a lot of creativity. So you'll see just a brief snapshot of some different projects we've worked on. And I might just shout out what you're seeing a little bit as we go through. So these were designing anemometers.
And each time we see this black cup, that tells us how fast the wind's going. 14, 15, 16.
So they created those themselves. I gave them the problem. I said that my niece needed help figuring out a device that would measure the wind speed because all her peers were like, oh no, disagreeing with her opinion about the wind. Because we come in, some of us think the air is cold, some of us think it's warm. We know that our teacher Beverly wears like 3 jackets at recess when I wear a t-shirt. Okay, so how do we be more precise about explaining the weather? So that's a little background on that.
What is this on the top? No, but look at how this is getting wet, so it has to at least...
So it will eventually drip out.
We use our data to kind of use, like, think about how much water would go through, but we kind of rounded them, so we kind of use that amount that let the least water through, so well, not least, but like medium.
You use the materials that let the least water through?
Yeah, but we use it.
Design a model membrane. We're imitating science and nature through engineering to create a little habitat for a frog. Can't have too much water going in, but you have to have enough for keeping the environment moist. And they were testing their design and gathering, and they had already tested materials out. And testing materials is a huge part of engineering.
And it will roll down this inclined plane with the falling levers, which will activate this crate that will slide down another inclined plane, which will hit more.
So we brainstormed with the 7th graders, and they got it. So we made a little box.
Cool.
3, 2, 1.
Good.
Woo! Yeah!
Depends on how many ships they run and whatnot. So to deal with that many ships.
Yeah, okay. We build machines that build these chairs. Okay? They were previously built by hand, and our machine now builds them for them. And you know how many chairs we build a year? Take a guess.
1,000! Million!
Who thinks it's a million?
620.
Who thinks it's more than a million?
620.
Well, it's a little over 2 million chairs.
Whoa.
That's a lot of chairs.
What I said is the brains of the machine. This is where all the different electrical signals come from and go to and move around. Like there. See? Nice in. That sensor can go.
100 milliliters, Danny, so you gotta just pour it all in. Okay.
Should we start ours? Oh, I'm really scared, guys. What if we fail this? Don't say that. Being optimistic.
It's okay to fail. That's how we learn. We learn. The goal is to give the frog water, little bits of water, over 24 hours, right? Julia, is that as good as it could be? No. Could you improve it?
Guys, I have an idea.
So let's say that again. Is it as good as it could be?
No.
Can you improve?
Yeah.
Good. last takeaway message, last food for thought is your children need to experience failure in order to succeed. And they need to be supported at home with that too. They're not going to succeed on everything in the science lab or in their classroom. And they have to be able, that toughens them up, right? And I really hope that our culture can grow in that way too, because that's an important thing that is needed in science. A lot of scientists say they fail 100 times before, you know, they finally get things right. So, all right.
Thank you.
That's it. Thank you.
Failure idea, I think, is really essential. And if the kids aren't failing on a fairly regular basis, then we're failing. We're not challenging them enough and not giving them opportunities to grow. So that's a really important idea. And one other thing I just wanted to follow up Kirsten's presentation. This is a model that we think is the most effective way for teachers to grow. We can't afford to send the entire lower school faculty to California for a conference, but to send a representative from each grade level with Kirsten as the science specialist to accompany them. They bring back those ideas. They've already shared out those ideas to colleagues. Those are already being implemented in the classrooms. Next week we have an in-service day where they're going to share those ideas with more colleagues and be able to follow up and to support their colleagues going forward as they implement these ideas. It's a great model for how to improve teaching and learning. And I think Christian, our Director of Technology Integration, Christian Waters, has a couple of things that he wants to share with us about what's going on in the middle school and with technology.
Great. Would everyone mind standing up really fast and just kind of holding your hands up above your head, kind of whacking one, maybe touching your toes once or twice, sitting for a while. We as educators know it's really hard to learn if your blood isn't flowing through your body and you're motionless, and so good. Everyone's moved around a little bit. All right, so I'm here to speak to you specifically today about the hour of code. And if you prefer to stand, I won't be offended. So the Hour of Code is an initiative that was launched by educators, a nonprofit organization, code.org, as well as industry leaders. And their whole, one second here. There we go. So the Hour of Code's whole sort of raison d'etre is to kind of get kids learning computer science and learning how to code, because there is a dearth of computer science majors in college. We're really doing a disservice to kids when we don't teach computer science. And so there's been a big push to really emphasize that in schools. And so we embraced it, and we have not only integrated it into some of our classes that we're teaching, but we're also designing future courses and current courses in computer science in the middle school and upper school that really emphasize and really focus on some of these concepts. So why teach coding? So this guy is kind of a celebrity here. Everybody in the country should learn to program a computer because it teaches you how to think. And I definitely agree with that. Myself, as I have been learning some of these coding languages, have really been kind of humbled by how much my mind is stretched as I try to help a robot navigate through a maze, or design a coding program that will make lights blink, even something as very simple as that. So I think it's a great sort of a metacognitive way for us to think about thinking by using coding. Here's what coding helps us do. It reinforces logic, problem solving, spatial awareness, computational and sequential thinking. It helps us to decompose big problems that were maybe seemingly insurmountable before, and kind of decompose them into smaller steps and say, okay, how can I tackle this one step? And of course, this isn't just applicable in coding, it's applicable in all challenges we face in life, or giant math problems. How can I sort of take one chunk of this and solve it one step at a time? And the last thing is prototyping, and this is a skill that they're working on in lower school science and upper school science. taking one stab at something that we know may or may not be right, maybe seeing it fail, but then learning from that failure and trying it again. That's the process of prototyping, is an iterative process. We're learning at each step of the road. So when kids in the lower school, for example, build a robot, that robot is destined to fail the first time. And then it gets a little better the second time. And then maybe they add either some code or some parts that will make it more successful. So that process of prototyping is not only a coding process, but it's also a life skill as well. So the Hour of Code, it's been hugely successful. It was started in 2013. Over 10 million girls tried computer science in 2013. That is more than the previous 70 years combined. So it's really reaching a broad array of students, not just the boys, I'll just say it, who would self-select because they're computer nerds or whatever. It's reaching a broad array of students who may not have been exposed to these concepts before. And over 99 million people have tried the Hour of Code since 2013. That's huge. In fact, the Hour of Code in 5 days reached 15 million users. And you can see all of these social media platforms. Facebook took 3 years to reach 15 million people. So it's a huge success. I'm not saying that all 15 million of these people are going to go on to become computer science majors. That's not the case. But at least they know what it's like. At least they've had some experience and and they've been exposed to it. So when we start talking about these things, we're really, we do a lot of what we call unplugged computer science activities. And it's important to understand that you can play a game, you can kind of code on a computer, but you can also take a step back and think rationally about what a computer is doing. How does a computer process these commands? So that's what unplugged activities help us learn. So this is a middle school group that's learning about image representation. They've got a list of numbers and they're trying to, on a grid, represent those numbers visually, just like a fax machine would, for example. These kids are not from our school, but we do this activity all the time, which is counting by binary numbers. So you're given zeros and ones. How does a computer take those bits and turn them into a number, an actual number that's not a 0 or 1? So we kind of, using little cards, we have to flash those cards in order, and students have to try to guess what number that's representing. This is a really fun activity. This is a cup stacking activity where students are given a series of very easy symbols, up arrows, down arrows, left and right arrows, and they have to then tell another student, who is the robot, how to stack these cups. So they're learning how to think computationally, sequentially, and logically, but they're not necessarily learning JavaScript, right? Which is this huge, coding language that involves a lot of syntax and a lot of correct, kind of coding grammar. They're just using arrows and they're working with their friends. So they're learning the basics of coding without necessarily needing to learn the entire language. So very briefly, this is a student in the middle school who did the Hour of Code. She played a game and she learned a program called Python, which is a very popular coding language out there. Let's see, I've got to find the volume here. I need tech support.
I'm Emily Orphanakis, and I played this game, Code Combat, for about 2 hours at school and home. This game was very fun. It's a good way to learn coding. Before this game, I didn't understand how much coding meant. It's a lot easier than you think it is.
So that was just one brief snapshot of one student. And then, so this is kind of moving beyond the Hour of Code. Now we're not just focusing on little tutorials or little games. What can students make? What can they build with this knowledge of coding? So these are two girls who I was very impressed with in one of my computer science classes I teach in the middle school. They created this, they designed a video game, they made a controller that interacts with the computer, all by integrating coding into their lesson or into their activity.
Hi, my name is Violet. And I'm Maya. This is our game. It's quite a bit of code. Yeah, so this one's for the red sprite, which is what you are, is for the maze cover. Yeah.
So this is the maze game, and this is our makey board, and how it's connected is actually all on the back.
Make it quickly because we need to start connecting.
So we're gonna show everyone how to play our game.
We had a couple of boys in the middle school, Luke Kraskowiak, Ford Paradise, and Nicholas Muscondas, who created this beautiful, I mean, you know, for us it's kind of a blinking thing, but this inside is a little Arduino that they had to code, and they had to tell it, you know, what color lights, how often to blink, and now it's just a beautiful little light sculpture that they designed and created for this class. So that's what can be made once you know a little more about coding. I brought some iPads. I was going to allow everyone to kind of try a game, but I think we're running a little over on time, so we'll maybe cut that out of the presentation. But if you'd like to know more, this is a great website, code.org. They've got a lot of resources, and if you're interested in doing something either yourselves, which I recommend, it's tons of fun, or with students, feel free to email me or speak to me about any resources that you may want to play with. So thanks, guys.
Thanks to Christian for paying closer attention to the time than I have. I just had one more thing that I wanted to mention. The high school hasn't gotten a lot of discussion today, but we're really excited about some new opportunities that the students are going to have in the high school with science and mathematics in the coming years. I invited Mr. Titomer here to tell you about his aviation science class, and then he had to go back and teach because we ran long. If you don't know Bill Titomer, he's one of our middle school math teachers. He's a former Navy pilot. He's written instruction manuals for the Navy. He is an amazing resource for our community, and we're going to start taking fuller advantage of that resource. He's going to teach an aviation science class for juniors and seniors in the high school next year. It will incorporate physiology, physics and aerodynamics, meteorology, and other areas of science. And it is a course that will earn credit at Westminster College. There's a 3-hour flight training course at Westminster that the students will be concurrently enrolled in. And if they are successful in Mr. Tomer's class, they'll get those 3 credit hours from Westminster, and also be prepared to take the written exam for their pilot's license at the end of that course. So it's a great opportunity. 2 other electives that are probably going to be offered during the seminar time in the upper school next year, an ornithology elective from Rob Wilson, who's our biology teacher, and that would be taught in the spring semester when the students would have the opportunity to go out and do field studies with the birds. And the other elective I hope to teach during that seminar time, and it would be a medical physiology class. I'm a physiologist by training, and it would be for students who are thinking about some sort of medical career in the future. So really excited about those science opportunities. And then in the mathematics arena, the mathematics department has started a process to add an advanced topics mathematics class that goes beyond BC calculus. So right now, the pinnacle course for us in mathematics is advanced placement calculus BC, which is the equivalent of a full-year calculus course for science and engineering majors. It is a challenging class, but we have students who, if we adjust the sequence a little bit, could potentially take that course as 11th graders, and then that would open the door for those most advanced math students, those kids to have a chance to take a course beyond BC calculus. So our math teachers are working on that, and the calendar is for next year to do the planning. The following year, they would have the first year of the new sequence change, and in 2017-18, there would be this advanced topics mathematics course that would be the equivalent of a second-year university mathematics course for science and mathematics majors. It's an impressive and daunting task, but I think they're up to it, and it's a great thing that they started this process on their own, and I'm sure that they'll successfully see it through.
So are there any programs for bringing along the kids in the upper school who didn't have the advantage of all the stuff that's not going on in the lower and middle school to introduce them to these ideas and to like get them in the mode of thinking? So now they're sort of see themselves as unsuccessful in math or science, to sort of kind of give them more self-confidence and sort of bring them along more.
Okay, first of all, I hope that the principals that are here in the room with me, Carol, I see, and Lee, and Alan can't talk, but maybe Jennifer, you guys could come forward, because I would love to have you join me, because we may want your insights in answering some of these questions. So first of all, I don't think that the students in middle school and high school currently have been deprived of really...
But there are some. I mean, granted, my kid came in high school, so she didn't get the lower and middle school stuff. But
I think it's the thought processes that she's wondering about, because those are invaluable. And the earlier that they can start seeing the world that way, then the better they're going to be.
I agree, and I know that one of the things that will be nearest and dearest to my heart as a science teacher, a career science teacher, is to work with the science teachers in the upper school on some of those ideas, the teaching and learning ideas. Because I think there's a lot of room in every classroom for teachers to explore new opportunities and to improve. And the first semester, first half of the school year, I've spent here trying to get to know teachers and trying to establish trust, because that's the only way I'm going to be able to work with them in the future. But moving forward, that's definitely something that will be a focus for me in the latter half and the third trimester of this year, and certainly starting fresh next year, to work with those teachers about some of those ideas. High school teachers, upper school teachers tend to be a little more entrenched in their worlds. They just by nature, and this has been true at every school I've ever been associated with, they're just a little more autonomous, and we want to break those teachers out of that. But we can't do it by force. We have to encourage them to come out and start collaborating and start thinking about these ideas in a broader way. So I think we're moving in that direction, but we can't force it.
But I do think, if I understood the question, part of what we're trying to do is getting kids accustomed to failure. We're working with the 9th grade program that we've introduced in the seminar, talking about mindset, and we've been doing a study, if you know the work of Carol Dweck and her thought about a positive mindset and a flexible mindset that means that you can progress better, and failure is an option, right? So we are taking steps, and even those kids that haven't sort of learned to fail from the earliest stages here, or as you saw it represented in some of the videos in lower school and middle school, we're talking about those ideas, and teachers are embracing those ideas. What's interesting is, and I think this is an evolving area of research, is that younger kids are kind of accustomed to failing and playing, and in gaming, for example, one of the things that is so fascinating is that you have to fail hundreds of times until you can get to that next level and get that sword or get that emerald or whatever it is. But there is a certain mindset of high school kids, and I think it's an outcome-based mindset, that failure isn't okay. And we keep, no matter how much we try as adults to make that clear, to preach that, to try to teach that, it's a tough nut to crack, because I think kids are accustomed to this notion that if I fail here, it means that 4 years from now I'm not going to achieve, getting into the college of my choice or something like that.
Well,
yeah, back here.
So using the term that it's okay to fail is a little concerning to me. I mean, I understand the concept, and to me that's equating to trial and error.
Right.
And so, I mean, the difference of the terminology and how setting up someone to fail can be small or it can be big. And I'm just wondering how you equate that to the other terminology of trial and error, and keep going back and not failing and giving up, but keep at it.
Yeah, that's a great point, and I certainly don't mean that, okay, you should come in and fail out or two.
Way to go! Just to clarify, because we keep using the term, it's okay to fail, and that kind of diminishes the whole thing of, okay, I failed, fine, you know, and it's not a big deal. And to me, it's more the trial and error, which is still the trial and starting back again and back again.
Right, it's about the struggle, and that's the point that I was trying to make earlier when I said, if they're not failing, then we're failing because we aren't challenging them enough. We have to keep raising the bar. We have to keep challenging them to reach their fullest potential. But we have to do that in an environment where they feel okay about going for that. If they're worried about failing, then they never try. So that's the part we want to promote about failure, not the actual.
I understand.
And this is maybe too detailed for this meeting, but I think that there needs to be a rethinking of partial credit and how it's given on answers to problems, on tests and things. I think that I have a real issue with the way that partial credit is given, that I think that's not right. It's that there needs to be better partial credit. Like you need to be able to get some of it wrong and still pass the test. Personally, it may be too detailed for this meeting.
Well, yeah, I was going to say that may be sort of a drill down. Let's not go too far into the weeds. I think philosophically we would absolutely agree with you.
Absolutely.
So why don't we talk after if there's some specific areas that you're concerned with.
Part of encouragement in science or humanities or anything is inspiration, not only from your teachers, but from what you're learning about the world. With the university right here, what are you doing to bring, either opportunities for the kids in the university, bring teachers from the university to the high school to excite them? Someone might be inspired to continue in science based on stuff they're hearing outside of the regular teachers or classroom experience.
Well, we have brought two university researchers to do presentations for students in the high school this year. Dr. Kay, who was a nationally known expert in Ebola and viral infection, and he came and did a presentation for the middle school and then a separate one for the high school. It was really terrific to see the students once they finally got engaged. The conversation and the dialogue back and forth was terrific. And then a couple of weeks ago, Carrie Kelly, who is on the state air quality board and is on two of the research groups at the university who are studying not only the scientific elements but the social and economic impacts of the air pollution. She came and gave a presentation for the high school, and Ben Smith's environmental science class were ready with really terrific questions, and it was a great conversation. And Dr. Kay has already told me that he's willing to consider bringing interested students into his lab, potentially for an internship this summer. And I've already talked to some of the high school teachers to be looking for those students in the AP biology class and the chemistry and AP chemistry classes, who are some students that are showing that kind of interest, and then we can steer them in that direction. And so we're trying to, and I'm new here, but I've learned quickly that if I send these people emails, a lot of times they answer me. Sometimes they even come. So I think we want to do that more and more, and we're moving in that direction, I think.
The other thing that we have started in the upper school and that I would love parental help with and outreach from folks in this room and beyond is creating an internship program that we've opened. We piloted this last year, and we had, I think, 7 or 8 internships, many of which were in the sciences, and instantly had kids who applied and filled those internships and came back with great experiences. So most of those folks have agreed to continue and do it again for another year, but I would love to have help in outreach to specific people that you might know who would say, and not just in the sciences, but in any field, because that opportunity to take what you've learned or been exposed to and spend a summer working in a lab or working with a professional is just unbelievable experience for kids. So if anybody here, I've put this in the flying line a couple times and had a handful of responses, not as near as many as I would like to, So we're trying to build an impressive array of those kinds of experiences.
Other questions? Thank you all for coming. It was great to see you. And if you have more questions, we'll be here afterwards. And thanks to the board and Home and School for allowing us to do this joint meeting.
Thank you.